Hello, my dear student. Hope you all are well. Welcome to Amader Pathshala. Today I am here just to teach all of you Higher Math first paper of class 11 and 12. You just see that class 11 and 12 Higher Math first paper, Higher Math second paper. Our today's topic is inverse trigonometric function, chapter 7, exercise 7.1. This is my lecture number 2 on inverse trigonometric function. Okay, dear student, at first, now we'd like to see learning outcome. You just see that at the end of the lesson, we all will be able to review of the last class, I mean lesson number 1. Then explain some important relations, then discuss fundamental relation among inverse function and trigonometric function. Then we will discuss mathematical problem. Dear student, now we would like to review of the last class, I mean previous class. Some important relations we have already learned in the preceding class. You just see that. First one, sin inverse x equals to x. Then you just see that cos inverse x equals to x. Then tan inverse x equals to x. Then cot inverse x equals to x, etc. Then some more important relations, sin inverse x equals to cosec inverse 1 by x. Next one, cos inverse x equals to sin inverse 1 by x. Next, tan inverse x equals to cot inverse 1 by x, etc. Some important more relations we would like to see. Dear student, you just see that sin inverse x plus cos inverse x equals to pi by 2. Then tan inverse x plus cot inverse x equals to pi by 2. Then you just see that sec inverse x plus cosec inverse x equals to pi by 2. We have already learned it. More important some relations, sin inverse x equals to, you just see that cos inverse root 1 minus x square. Similarly, cos inverse x equals to sin inverse root 1 minus x square. Then tan inverse x equals to sec inverse root 1 plus x square. Then sec inverse x equals to tan inverse root x square minus 1. Then cot inverse x equals to cosec inverse root 1 plus x square. Then cosec inverse x equals to cot inverse root x square minus 1. Okay, then you just see that some important more relations. Sin inverse, we have already learned and explained in the last class. Sin inverse x plus sin inverse y equals to sin inverse x into root 1 minus y square plus plus y into root 1 minus x square. Similarly, sin inverse x minus sin inverse y equals to sin inverse x into root 1 minus y square minus root 1 minus y 1 minus x square. Cos inverse, now we would like to see cos inverse x plus cos inverse y equals to cos inverse xy minus root 1 minus x square into 1 minus y square. Then cos inverse x minus cos inverse y equals to cos inverse xy plus root 1 minus x square into 1 minus y square. Okay, we would like to see the next slide and some more important relations on inverse trigonometric function. You just see that tan inverse x plus tan inverse y equals to tan inverse x plus y by 1 minus xy. Tan inverse x minus tan inverse y equals to tan inverse x minus y by 1 plus xy. Okay. Then tan inverse x plus tan inverse y plus tan inverse z equals to tan inverse x plus y plus z minus xyz by 1 minus xy minus yz minus zx. Okay. Then you just say that, dear student, some important more relations. 2 tan inverse x equals to sin inverse 2x by 1 plus x square equals to cos inverse 1 minus x square by 1 plus x square equals to tan inverse 2x by 1 minus x square. Okay. Then we are going to the next slide. Dear student, You just see that. Now we'd like to see some mathematical problems. At first we are going to prove that sin inverse minus cos x plus sin inverse cos 3x equals to minus 2x. You just see that. Left hand side, sin inverse minus cos x plus sin inverse cos 3x. You just see that sin inverse minus x equals to minus sin inverse x. So sin inverse minus cos x equals to minus sin inverse cos x and sin inverse cos 3x. Then sin inverse, you just see that minus sin inverse, this cos x, we can rewrite this into the form sin pi by 2 minus x. Okay. Similarly, this plus sin inverse and cos 3x we can rewrite into the form sin pi by 2 minus 3x. You must keep this in your mind, cos theta, since cos theta equals to sin pi by 2 minus theta. That's why we have written in this form. Okay. Next line. This sin and sin inverse will be cancelled, so it will remain here only minus pi by 2 minus x. Similarly, it will be here sin inverse x will be omitted, then it will be pi by 2 minus 3x. Okay, then minus pi by 2 minus x plus pi by 2 minus 3x. This minus pi by 2 and pi by 2 will be cancelled, so it will remain only here x minus 3x. So it will be minus 3x. This is the right hand side. That is sin inverse minus cos x plus sin inverse cos 3x equals to minus 2x, hence proved. Okay. Now we are going to see another problem, I mean problem number 2. You just see that. Prove that 2 tan inverse x equal to 2 tan inverse x plus tan inverse x cube. Okay. You just see that left hand side tan 2 tan inverse x. This 2 tan inverse x, you just see that we have already learned this formula 2 tan inverse x equals to tan inverse 2x by 1 minus x square. That's why we have rewrite in this form this 2 tan inverse x equals to tan inverse 2x by 1 minus x square. This tan and tan inverse x will be omitted, that's why it will remain only 2x by 1 minus x square. So left hand side will be 2x by 1 minus x square. Now we are going to see the right hand side. Okay. Then this is the right hand side. You just see that 2 tan inverse x plus tan inverse x cube. Okay. You just see that we have already learned tan inverse x plus tan inverse y equals to, what was the formula? Formula was tan inverse x plus y by 1 minus xy. X is x here and y is x cube. So it will be tan inverse x plus y, that is x cube, by 1 minus x into y, that is y is y cube. Okay. You just see that. Okay, next line. This 2 tan inverse, if we take common from here x, then we will get x into 1 plus x square. And this 1 minus x into x cube, it will be 1 minus x to the power 4. If we rearrange into the form 1 square minus x square whole square, then we can apply the formula of a square minus b square. What is the formula of a square minus b square? A plus b into a minus b. Then it will be 1 minus x square into 1 plus x square. Okay. Next line, you just see the next line. This 1 plus x square and this 1 plus x square will be cancelled. From the numerator and denominator, by cancellation method, we can cancel 1 plus x square. Okay. Since they are 1 plus x square is common factor, and this tan inverse x will be omitted according to the formula. This 2 into, so it will remain only x by 1 minus x square. 2 into x by 1 minus x square, so it will be 2x by 1 minus x square. Okay. Dear student, you just see that. So we can say that tan inverse 2 tan inverse x equals to 2 tan inverse x plus tan inverse x cube, hence proved. we are going to see the next one. We are going to see the next one. Problem number 3. Prove that cos inverse 1 by root 5 minus 1 by 2 sin inverse 3 by 5 plus tan inverse 1 by 3 equals to tan inverse 2. Now we are going to prove this. This is the left hand side. Cos inverse 1 by root 5 minus 1 by 2 sin inverse 3 by 5 plus tan inverse 1 by 3. Left hand side, you just see that cos inverse 1 by root 5, 1 by 2 sin inverse 3 by 5. This first two term we see that first two term will remain same here. Okay. Then you just see that third term we can rewrite into the form half into 2 tan inverse x. Now what is our target? Our target is we are going to apply the formula of 2 tan inverse x equals to sin inverse 2x by 1 plus x square. You just see there. You just see the next line. Cos inverse x, this first term will remain same, and the second term half sin inverse 3 by 5, it will remain same. Then this half into 2 tan inverse x, tan inverse 1 by 3. You just see that 1 by 3 we are considering that x. 2 tan inverse x equals to sin inverse 2x by 1 plus x square. Now we are applying this formula here. 2 tan inverse 1 by 3. Sin inverse 2 into x is 1 by 3 by 1 plus x square, that is 1 by 3 whole square. Okay. You just see the next line. Dear student, pay attention. Okay. You just see that cos inverse 1 by root 5 minus sin inverse 3 by 5 plus half sin inverse 2x, that is 2 into 1 by 3. It will be 2 by 3 in by 1 plus 2 1 by 3 whole square. It will be 9 by 10. 9 by 10. Okay. Into 9 by 10. Then cos inverse 1 by root 5 minus sin inverse half sin inverse 3 by 5. Then half sin inverse. If we express this part into the list form, then it will be 3 by 5, because 2 and 5 it will be cancelled. 5 will be here, and if we divide 9 by 3, then we will get 3. Since 9 3 3s are 9. So you just see that this part and this part is same. Second term and third term is same. So it will be cancelled. So ultimately next line will be cos inverse 1 by root 5. Okay, we just see that cos inverse 1 by root 5. Next line, you just see that if we think that cos inverse 1 by root 5 is a theta, it is a right angle triangle. So cos theta, what is the ratio of cos theta? Cos theta equals to adjacent by hypotenuse. Adjacent is 1, hypotenuse is root 5. So what is the opposite? Opposite equals to square root of hypotenuse square minus adjacent square. That is root 5 case. If we make square of root 5, then we will get 5, and if we make square of 1, then it will be 1. 5 minus 1, this is 4. Square root of 4 is 2. So opposite is 2. Now you just see that. So tan, what is the value of tan? Tan theta equals to opposite by adjacent, that is 2 by 1. 2 by 1 means 2. So theta equals to tan inverse 2. That's why tan inverse 2. This is the right hand side. Okay. Hence cos inverse 1 by root 5 minus 1 by 2 sin inverse 3 by 5 plus tan inverse 1 by 3 equals to tan inverse 2. Hence proved. Okay. Dear student, we are going to the next slide. Now we are going to prove that 2 sin inverse x equals to sin inverse 2x into root over 1 minus x square. You just see that let sin inverse x equals to theta. So tan sin theta equals to x. Okay. Then you just see that we know that sin 2 theta, we know that this formula from the trigonometry, sin 2 theta equals to 2 sin theta cos theta. Okay. So sin 2 theta equals to 2 sin theta cos theta, we can rewrite into the form square root of 1 minus sin square theta, because we have already learned from the secondary level, sin square theta plus cos square theta equals to 1. So, cos square theta equals to 1 minus sin square theta. That is, cos theta equals to square root of 1 minus sin square theta. Okay. Then next line, sin 2 theta equals to, since sin theta equals to x, so it will be 2x into root over 1 minus x square. Here we are putting the value of sin theta. Okay, so 2 theta equals to sin inverse 2x root over 1 minus x square. What is theta? Theta was sin inverse x. So next line will be 2 sin inverse x equals to sin inverse 2x into root over 1 minus x square. We just see that 2 sin inverse x equals to sin inverse 2x into root over 1 minus x square. Hence proved. Okay. Then we have already completed this problem. Next line, we are going to see the next problem. Problem number 5, prove that if sin inverse 2a by 1 plus a square minus cos inverse 1 by minus b square by 1 plus b square equals to 2 tan inverse x, then we are to show that x equals to a minus b by a plus ab. Okay, you just see the solution of the problem. We have already learned a formula like this: 2 tan inverse x equals to sin inverse 2x by 1 plus x square equals to cos inverse 1 minus x square by 1 plus x square equals to tan inverse 2x by 1 minus x square. This is the relation number 1. Okay, you just see that next one. Given that sin inverse 2a by 1 plus a square minus cos inverse 1 minus b square by 1 plus b square equals to 2 tan inverse x. If we apply the relation 1, so sin inverse 2a by 1 plus x square, it will be 2 tan inverse a. Okay. Similarly, if we apply the relation of 1, cos inverse 1 minus b square by 1 plus b square, we can rewrite this into the form minus 2 tan inverse b equals to 2 tan inverse x. I mean the right hand side will remain same. Okay, then you just see that or 2 tan inverse x equals to 2 tan inverse 2 into tan inverse a minus tan inverse b. We are taking common from the right hand side 2, and then we interchange the left hand side and right hand side. If we divide both sides by 2, then we will get tan inverse x equals to tan inverse a minus tan inverse b. Okay, then you just see that. So this tan inverse x equals to, we have already learned a formula like this: tan inverse x minus tan inverse y. Its formula was tan inverse x minus y by 1 plus xy. So it will remain tan inverse x equals to tan inverse a minus b by a plus b. If we omit tan inverse this operator from the both sides, then we will get, you just see that x equals to a minus b by 1 plus ab, hence short. Okay, now we are going to see the another problem, I mean problem number 6. You just see that it is a very important question. Prove that 2 tan inverse root 1 a minus b by a plus b into tan theta by 2 equals to cos inverse b plus a cos theta by a plus b cos theta. Okay, now we are going to see the solution of the problem. We have already learned a formula like this: 2 tan inverse x equals to cos inverse 1 minus x square by 1 plus x square. This is the relation number 1. You just see that left hand side was 2 tan inverse square root of a minus b by a plus b into tan theta by 2. Okay, then we are applying this formula, the relation number 1, 2 tan inverse x equals to cos inverse 1 minus x square by 1 plus x square. Here what is x? X is within the first bracket, that is root 1 minus b by 1 plus b into tan theta by 2. Okay, so it will be cos inverse 1 minus x square. So it will be 1 minus root 1 minus a minus b by a plus b into tan theta by 2 whole square by 1 plus root a minus b by a plus b into tan theta by 2 whole square. That's why we have written by 1, by relation number 1. Okay. Then next line, cos inverse 1 minus square and root will be cancelled. So it will be a minus b by a plus b, and the power root will be distributed. So tan theta by 2 whole square, it means that tan square theta by 2. Similarly, in the denominator part, it will be 1 plus a by b by a plus b tan square theta by 2. Next line, if we make LCM, then we will get a plus b minus a minus b into tan square theta by 2. So if we multiply the numerator and denominator by a plus b, then it will be a plus b minus a minus b into tan square theta by 2. Similarly, in the denominator it will be a plus b plus a minus b into tan square theta by 2. If we take common a from the numerator, then a into 1 minus tan square theta by 2, and if we take common plus b from the numerator, then b into 1 plus tan square theta by 2. Similarly, in the denominator, it will be a into 1 plus tan square theta by 2 plus b into 1 minus tan square theta by 2. Okay. You just see that next line. If we divide the numerator and denominator by 1 plus tan square theta by 2, then it will be cos inverse a into 1 minus tan square theta by 2 by 1 plus tan square theta by 2 plus b. And in the denominator, it will be a plus b into 1 minus tan square theta by 2 plus 1 plus tan square theta by 2. What is the formula of this? Cos theta equals to 1 minus tan square theta by 2 by 1 plus tan square theta by 2. That's why we have written, you just see that, we have written within the third bracket, cos theta equals to 1 minus tan square theta by 2 by 1 plus tan square theta by 2. So it will be a into cos theta plus b by a plus b cos theta. Ultimately, our right hand side has been proved. That is cos inverse a cos theta plus b by a plus b cos theta. Okay. You just see that this is the right hand side. So 2 tan inverse square root of a minus b into tan inverse theta by 2 equals to cos inverse a cos theta plus b by a plus b cos theta. Hence proved. Okay. Now we are going to see another problem. Dear student, prove that sin inverse cot inverse tan cos inverse x equals to x. Okay. You just see the solution of the problem. Left hand side, sin cot inverse tan cos inverse x equals to, you just see that if you think that cos inverse x equals to theta, so cos theta equals to the, you just see the adjoining right angle triangle. Cos theta, what is the ratio of cos theta? Ratio of cos theta is adjacent by hypotenuse. So adjacent is x and hypotenuse is 1. So what is the perpendicular? Opposite. Perpendicular means opposite. Opposite equals to square root of hypotenuse square minus adjacent square. That is square root of square means 1 minus x square, since adjacent is x. So there is tan. So tan theta equals to root opposite by ratio. Tan theta ratio is opposite by adjacent. That is tan inverse equals to tan theta equals to root 1 minus x square by x. So theta equals to root 1 minus x square by x. That's why you have written sin cot inverse tan inverse root 1 minus x square by x. Okay. Just see the next line. Sin cot inverse, this tan and tan inverse will be omitted. So it will be root 1 minus x square by x. Okay. You just see the next one. We have already drawn another right angle triangle. This, if we think that this is theta, so cos theta, the value of cot theta equals to root 1 minus x square by x. Cot theta, what is the ratio of cot theta? Cot theta is adjacent by opposite. That is, adjacent is root 1 minus x square, opposite is x. So what will be the hypotenuse? Hypotenuse equals to root adjacent square plus opposite square, that is root 1 minus adjacent square is root 1 minus x whole square plus x square, that is 1 minus x square plus x square equals to x square will be cancelled, so it will be remain 1. Square root of 1 is 1. So you just see the next line, sine inverse. If we write the cos inverse, cos sine theta equals to opposite by hypotenuse, that is sine theta equals to x by 1, that is sine theta equals to x, so theta is equal to sine inverse x. So sine inverse x, then this x is here, this is the right hand side. Okay. So ultimately we have already reached our goal, that is sine cot inverse tan cos inverse x equals to x, hence proved. Now we are going to see the another problem, problem number 8. Prove that sine inverse root sine theta plus sine inverse root cos theta equals to pi by 2. Solution, you just see the solution of the problem. Left hand side, root sine inverse root 2 sine theta plus sine inverse root cos 2 theta. Then you just see that the first term will remain same. And if we think that this is theta, sine inverse, this is x, sine inverse x, we can convert into a relation. We have already learned sine inverse x equal to cos inverse root 1 minus x square. So it will be root 1 minus root cos theta whole square. Okay, you just see the next line, sine inverse root 2 sine theta plus cos inverse root 1 minus square and root will be cancelled, so cos 2 theta. Okay, you just see the next line, sine inverse root 2 sine theta plus cos inverse root 1 minus cos 2 theta, this is 2 sine square theta. Okay, then you just see that sine inverse root 2 sine theta plus cos inverse root 2 sine theta. We have already learned a formula like this, sine inverse x plus cos inverse x equals to pi by 2. That's why if we think that root 2 sine theta is x, then this root 2 sine theta will be x. So sine inverse x plus cos inverse x equals to pi by 2. Applying this formula, we can rewrite this pi by 2. This is the right hand side. So left hand side equals to right hand side proved. Now we are going to see another problem. If sine inverse x plus sine inverse y equals to pi by 2, then show that x root 1 minus y square plus y into root 1 minus x square equals to 1. Okay, you just see the solution of the problem. Given that sine inverse x plus sine inverse y equals to pi by 2, then we can rewrite sine inverse x. We have already learned a formula like this, sine inverse x plus sine inverse y equals to sine inverse x into root over 1 minus y square plus y into root over 1 minus x square. Then equals to pi by 2. So if we think that this part is theta, so sine inverse theta equals to pi by 2. So theta equals to sine pi by 2. That is x root 1 minus y square plus y into root 1 minus x square equals to sine pi by 2. What is the value of sine pi by 2? Sine pi by 2 is 1. Okay. Dear student, I would like to give you some homework. You just see that. You just see that if cos inverse x equals to x by a plus cos inverse x equals to y by b equals to theta, then sin theta equals to x square by a square by 2xy cos theta by ab plus y square by b square equals to sin square theta. Similarly, if the solution of these two problems. Okay, thanks to all. No more today.